Hey there, so today we're going to talk about intercepts and turning points on this document, and it's fairly straightforward. I think a lot of it you are already going to know, and just so you can put a face to the voice, here I am. So this graph here is in blue. It is a cubic function, which we'll be learning about later. Right now you can see the x-intercepts are highlighted, pointed to the purple arrows here. X-intercepts can also be called zeros, roots, or solutions depending on what you're using them for. And just down here in the red box you can see the order that we want to write our x-intercepts, the x value first, y value second. On this page here, I've just highlighted for you the y-intercept. Should be no surprise. There it is right there crossing the y-axis, and it has coordinates of 0, 6. One thing I do want to talk about though, what we're leading up to, is being able to write increasing and decreasing intervals. If we look at this graph, it starts from left to right. It starts by going up or increasing, and then it goes down or decreasing, and then it goes up again, and that's increasing. The points where it changes directions, remember it was going up and then it was going down, where it changes direction, that's called a turning point. This turning point here is a maximum because it is a high point in the graph, and it's where the graph goes from increasing to decreasing. This point here, where the graph goes from decreasing to increasing, is called a minimum. And for those coordinates for now, we're just going to approximate what they are. So here you can see I've got approximately negative 1.8, comma 8.2. If you take calculus next semester, you will be able to calculate those exactly. Maximum and minimum points are also called extrema, and they can be classified as either local or overall. So I'll give you an idea of how we figure it out. Here, this one is called an overall maximum, and overall minimum, my bad. It's called an overall minimum because it is the lowest point on the graph. The graph doesn't get any lower anywhere else. Where over here, this one is also a minimum, but it's only a local minimum because, as you can see from over here, there are points somewhere else on the graph that are lower. So this one is only a minimum in this region of the graph. So it's a local minimum. This is the same way, a local maximum, because it's only the highest point in this region of the graph. We can see that there are points that are going to be higher over here when we look at the ends of the graph. So this graph has no overall maximum because there is no highest point. These ends are going to keep going and going, reaching up towards infinity.